Hello and welcome back. Today we have section 9.2 to cover, which is about the calculus and parametric equations. Last time we covered section 9.1 about the plane curves and parametric equations. So I have introduced the idea of parametric equations, some of the useful applications, how do we graph plane curves from the parametric equations. Today we're going to deal with the calculus of the parametric equation. So we'll learn how to find the first derivative, second derivative, tangent equation, slope of the tangent, and more. Now for the first derivative of the parametric equation, remember the definition of the parametric equation. So we have the function written as two equations. X is a function of t, and we have y as a function of t also. So here I have like x, y, and t, all of them involved in the parametric equation. So if I need to find the first derivative, it's coming from the chain rule. So if I'm finding dy over dt, so this is equals dy over dx times dx over dt. This is basically chain rule. What I'm using here is the chain rule. Now, if I just look at this equation and I try to solve it for dy over dx, okay, I'll solve it for dy over dx. This is what I get, this rule. So dy over dx is equal to, so this is means that dy over dx equals, you divide dy over dt, dy over dt divided by dx over dt. Okay, so this is from where we get this rule about the first derivative. Now let's try to apply one question. So we have these parametric equations, x equals sine of t, y equals cosine of t, and we need to find the first derivative dy over dx. Now I need to prepare, so I need dy over dx, it's equals to dy over dt divided by dx over dt. Okay, now this is equals to, check now, dy over dt, this is y. What's dy over dt? The derivative of cosine, it's negative sine of t. Down, it's dx over dt, the derivative of this x, so this is cosine of t. I could keep the final answer like this, or I could write it like nicer using the tangent. So negative sine over cosine is tan t. If I need the final answer to be in terms of x and y, so notice it will be equals to what? The sine is x, so this is negative x over y. This is in case I need the final answer in terms of x and y. Okay, so this is the first question, how to find the first derivative. Okay. Now see this one. Still we're dealing with the first derivative, but the question here asks me to find the equation of the tangent line, the tangent equation. This is what's required. So they give me parametric equations, and I need to find the equation of the tangent line at the point t equals 3 pi over 4. For that purpose, to find the equation of the tangent line, remember the general form of the tangent line equation. So I need the tangent line equation. Remember, the tangent is basically what? Straight line, right? The tangent is straight line, and we use this form, the point slope form. So this is y minus y1 equals mx minus x1. So this is the general form I'm using. So what do I need to get this tangent equation? I need one point, which is x1, y1, and I need the slope, which is m. Okay, so the first requirement to find this equation, I need one point. I need a point, which is x1, y1. Okay, how do we get this point? Okay, we have t. So if I substitute t in x and y, I'll get x1, y1 at this specific point. Okay, great. So the point will be x1 equals x1 of 3 pi over 4. If you replace this in the equation for x, so this is 4 cosine 3 pi over 4. If you use your calculator or you know the cosine for pi over 4, so this is basically equals negative 2 radical 2. Now y1, 3 pi over 4. Now I'll substitute in y, which is a 3 sine 3 pi over 4. And this is equals to 3 radical 2 over 2. Now this is the point. So now I know the point is equal to what? The point, I have it as negative 2 radical 2, 3 radical 2 over 2. Okay, so this is the point. Now we have the point already. Now the next part we needed to find the tangent equation, I need the slope. And remember, the slope always is what? The first derivative. I need the slope m, which is basically dy over dx at t equals 3 pi over 4. This is the slope. So I need the first derivative. Okay, fine. Let's do that. So I need dy over dx, okay, equals, we know this is equals dy over dt divided by dx over dt. And this is equals to, okay, let's check. Dy over dt, 3 sine, so this is now 3 cosine of t. And I need to find dx over dt, so this is negative 4 sine of t. Okay, now for this one, I need to find it at, I need the slope, it's dy over dx at t equals 3 pi over 4. So if I replace here, so it will give me the slope as 3 over 4. 3 over 4. So now this is the slope. Now I have the point and I have the slope. I'm ready to find the equation. I'm ready to find the equation. Okay, good. Okay, so the equation as written here, it's y, the tangent equation, tangent equation. We have it y minus, what's y1 in this case? Remember, this is x1, this is y1. Y minus y1, 3 radical 2 over 2 equals, the slope is a 3 over 4 times x minus x1. It's negative 2 radical 2. And we have negative in the rule, so this is positive 2 radical 2. Now this is almost done. What we need to do, just only the only step left is to simplify further. Okay, we can do that. So this is equals y equals, if you distribute the 3 over 4, so this is 3 over 4x plus 3 over 2 radical 2. And I'll move this one to the other side. So this is plus 3 radical 2 over 2. So basically I can write it as final result 3 over 4x plus 3 radical 2. And this is the tangent equation at the point at t equals 3 pi over 4. Okay, see what do we have next. Now the next part is to find the second derivative. We need to find the second derivative. Now to find the second derivative, maybe you think, okay, I need to find the second derivative of dy over dt over the second derivative of dx over dt, which is not the case. This is not true. So it's not that the common mistake that I usually see. So to find the second derivative, basically what we need to do, we have the first derivative already, right? Let's say to get the second, we need to find the first. So we'll find the first derivative, then I'll find for the first derivative, notice this is like you have d over dx for y prime of x. So this is equals to what from the previous one? Remember, we need to find dy prime over dt over dx over dt. This is basically the rule from the first derivative. So I need to find the derivative for y prime. So it's dy prime over dt. So I have y prime. I need to find its derivative with respect to t. And I'll divide the result by dx over dt. So basically what I need to do is just 3 steps. What I need to do is 3 fast steps. So first, I'll find the first derivative, just normally, dy over dx, as we covered in the first 2 examples. Then I'll find the derivative for the first derivative, but with respect to t. And then the last step will be whatever I have in the second step, I'll divide it by dx over dt. Just to get this, you see here, this is the derivative of the first derivative. So it's dy prime over dt. So y prime, I found the derivative with respect to dt, then I'll divide it by dx over dt. So basically we can summarize the steps into these 3 steps. Now let's try one more. One question. We need to find the second derivative as a function of t. So you see just here they specified, they needed to stay in t, as a function of t, no need to change into x. So x equals t minus t squared, y equals t minus t to the power of 3. Okay, we need first step to find the first derivative. Okay, let's find the first derivative. So dy over dx equals to, remember, this is equals dy over dt over dx over dt. And this is equals to dy, that's it, dy over dt equals 1 minus 3t squared. Dx over dt, it's 1 minus 2t. Okay, now this is the first derivative. Now for the first derivative, I'll find its derivative with respect to t. Notice here, this is like a quotient rule, okay? This is like a quotient rule, u divided by v. If I need to find its derivative, remember the rule, u prime v minus uv prime divided by v squared. Okay, let's do that. So now I need d over dt for the first derivative. And this is equals, okay, we'll try to find it. The derivative of the numerator, it's negative 6t times the denominator. Remember, the order here is important because the sign is negative. So you have always to start with the numerator. Derivative of the numerator times the denominator, and then minus. Now I do the derivative of the denominator, it's negative 2, and I have negative, so it's positive 2 times the numerator, 1 minus 3t squared, divided by the denominator squared. Now, with all these rational expressions, don't simplify the denominator, keep it as it is. Just do any further simplification for the numerator. So if you just use basic algebra to simplify the numerator, okay, basic algebra to simplify the numerator, this is what we get. So this will be equals to 2 minus 6t plus 6t squared. Just expand and simplify. Now this is the second step. Now the last step will be what? Only I take this step and I'll divide it by dx over dt. Okay, that's good. So this is like step, whatever I have from step number 2. So this is, now this is the second derivative, last step. Second derivative equals whatever I have from step number 2, which is 2 minus 6t plus 6t squared divided by 1 minus 2t squared. I'll divide this by dx over dt. Notice what's dx over dt? It's again 1 minus 2t. Now denominator divided by another denominator, so I'll multiply them. So this is equals 2 minus 6t plus 6t squared divided by 1 minus 2t to the power of 3. And this is the second derivative. So as you see, we went through 3 steps. First step, first derivative normally. Then for the first derivative, I apply the derivative rules to find the derivative with respect to t. Last step, whatever I have from step number 2, I divide it again by dx over dt. I divide it again by dx over dt. Okay, let's try one extra question on the second derivative. I need to find the second derivative. This is the same one, the solution. Okay, this one. I need to find the second derivative for x equals sine of t, y equals cosine of t. Okay, same question, but here I have trig parametric equations. I need to find the first derivative, fine, easy. So this is equals dy over dx equals to dy over dt divided by dx over dt. And this is equals to dy over dt. This is equals to negative sine of t. Dx over dt, this is cosine. And I can say that this is equals negative tan of t. Okay, this is the first derivative. Now for the first derivative, I need to find the derivative with respect to t. So d over dt for negative tan of t. And as you know, the derivative for the tan equals to what? Tan secant squared. Then I have negative, so this is negative secant squared t. Now the last step will be what? Whatever I have from step number 2, this is the second derivative. Final step is always the second derivative. So whatever I have from the second step, which is negative sec squared t, I have to divide it by dx over dt. Okay, again, what's dx over dt? It's cosine. Cosine of t. Now remember, this is okay. This is like a final result, it's fine. But if I need just to simplify it more, so I can write it as, remember, the secant is 1 over cosine squared, 1 over cosine squared. And I have another cosine. So this is like basically negative 1 over cosine squared. Cosine squared t. And I have down cosine of t. So this is equals negative 1 over cosine to the power of 3t. Okay? This is one way how to write it. I could write it as secant power 3 also. It's fine. Now see what do we have next. So now the first 4 examples, the first 2 were about the first derivative. The second 2 about the second derivative. Now the coming question is a bit similar. We're using the idea of the first derivative. And they tell me here I need to find the slope of the tangent line. It's not the tangent equation, it's easier. We need only the slope of the tangent line. And they give me the parametric equation at t equals to 0. Okay, we know once we ask about the slope of the tangent line, which is one of the very important applications of the first derivative. So we know the first derivative always is the slope of the tangent line. So now basically what do I need to find? The slope is equals to what? dy over dx at t equals to 0. This is what we need. Okay, that's fine. This is equals to, I need to find dy over dt. Remember, always dy, derivative of y in the numerator. I need the derivative for y prime of t. Let's write it this way. So I need y prime of t over x prime of t. And this is equals to, okay, y prime 2 cosine of t. Remember chain rule, here we have 2t, not only 2t. So this is negative 2 sine 2t. Down is the derivative for x, so this is negative 2 sine of t, and this is sine, so this is cosine. Don't forget the derivative of the argument, so this is 2 cosine 2t. And I need to replace here at t equals to 0. You can use your calculator directly, and it's really simple at 0. And this is equals to 1. So the slope here equals to 1 directly. Sometimes we're not that lucky. In this question, it was simple. We found the derivative, we replace it, we got the value equals to 1. Sometimes I have both derivatives, y prime of t and x prime of t, both of them equals to 0. If both of them equals to 0, then I need to do something else. I can't find it directly 0 over 0. In that case, I need to again use the idea of limits. So anytime I have x prime of t at any point c, let's say, which is t, x prime of c, y prime of c, if both of them equals to 0, so basically just like you're having 0 over 0. In that case, I don't find it at the exact c. I'll take the limit as t approaches to c. Okay, so it's not at the exact c. We'll find it as t approaches to c. Same thing. dy over dt divided by dx over dt, but we'll take it as a limit. And we'll see. If the limit exists, so that's it, we have the slope. If it does not exist, we'll talk about it in the next question. Now see this one, which is exactly the same question, right? Just as the one before, but we've changed t this time. In the previous question, we had t equals to 0, and we had the slope as 1. Now it's the same question, but we have t as a 3 pi over 2. Now let's try to get what do we have in this case. If it's a 3 pi over 2, let's try. So I have dy over dx. Okay, let's say here. dy over dx equals 2. We need dy over dt, which is, again, just as we found before. So this is 2 cosine of t minus 2 sine 2t. Down, it's negative 2 sine of t plus 2 cosine 2t. This time we replace it at t equals 3 pi over 2. So this will be equals, direct substitution, it will give 0 over 0, which is an issue in this case. So if I have it 0 over 0, then I need to use the idea of limit. So the idea of limit will be what? dy over dx equals the limit as t approaches to 3 pi over 2. For this derivative, 2 cosine of t minus 2 sine 2t divided by negative 2 sine of t plus 2 cosine 2t. Now, since the direct substitution, which we already see there, it's 0 over 0. Remember, this is a famous case. If you have 0 over 0, if you have plus or minus infinity over infinity, this is some of the cases that you're allowed to use L'Hopital rule. And remember the L'Hopital rule, what does it allow me to do? L'Hopital rule, once you have the direct substitution, one of these cases, you can find the derivative of the numerator divided by the derivative of the denominator. It's not the quotient rule, okay? So it's only like f prime over g prime. Derivative of the numerator over the derivative of the denominator, not the quotient rule. And then we'll try again direct substitution. If it's still 0 over 0 or infinity over infinity, you can apply L'Hopital rule one more time. If you have an answer, that's it, you stop. So here I'll use L'Hopital rule in this step, okay? From this equality, I'll use L'Hopital rule. It's a French mathematician. The H is silent. L'Hopital's rule. Okay. So for the L'Hopital rule, I need to find the derivative of the numerator divided by derivative of the denominator. Let's try. So this is negative 2 sine of t minus 4 cosine 2t divided by negative 2 cosine t minus 4 sine 2t. Now, once I use the L'Hopital rule, I'll try again with the direct substitution and see what does it give me. So if I do the direct substitution again, I'll get 6 over 0, which is equals to infinity in this case. This is undefined. So what can I conclude in this case? That the slope is undefined. Undefined. If the slope is undefined, what can I say about the tangent line? Remember, the line which has undefined slope, that means it's a vertical tangent. So hence, the tangent line is vertical. It's a vertical tangent. That's why its slope is undefined. So now again, for these cases, once you try to find dy over dx and your direct substitution gives you 0 over 0, then you have to use the limits as t approaches to that value, which is given 3 pi over 2 here. Now, since the direct substitution 0 over 0, you're allowed to use L'Hopital rule. We've used L'Hopital rule, we try again direct substitution. It gives me 6 over 0, so this is equals to infinity. So the slope is undefined, so we can say that the tangent line is vertical in this case. Now, if we look here, you can see the graph of these parametric, the parametric curve here. You see at t equals to 0 with it, which is part 1, part A, we found the slope as 1, which is clearly increasing tangent line. So the slope is positive. If I think at 3 pi over 2, as you see this red tangent line, it's a vertical tangent line. Okay, it's a vertical tangent line. Okay, let's see what do we have next. Now, since we're talking about the vertical tangent, horizontal tangent, so we need to get, is there any way to check whether we have a vertical tangent or horizontal tangent? Yes. Remember, any horizontal line, this is like basic knowledge. It's not only about the tangent line. So if I have in the xy coordinate, remember the slope always means the change, okay, the slope in general. The slope is the change of y over the change of x, rise over run. So if I have any horizontal line anywhere, so the slope in this case, if it's horizontal line, the slope is 0. There's no change. Okay? If you have any vertical line, okay, let's say that we have this. This is the x. Okay. So if I have any vertical line like here, so the slope will be undefined. The slope will be undefined. It's vertical line. Now, how do I get it? Just if I look at the dy over dx or the definition of the derivative, remember that dy over dx equals y prime of t over x prime of t. Now, if the horizontal tangent, if I have a horizontal tangent, this means that the slope is equals to 0. When do I have any fraction equals to 0? If the numerator equals to 0. So what's the condition? Y prime equals to 0 and x prime does not equal to 0. So this is the condition which guarantees that the tangent is horizontal tangent. So remember, just think about it as 0. When do I have any fraction equals to 0? Numerator should be equals to 0. Okay, so anytime you have a over b equals to 0, this means that a equals to 0 and b does not equal to 0. So it's not the case of 0 over 0. It's only 0 over a number, non-zero number. Okay, so horizontal tangent, the numerator 0, denominator does not equal to 0. We have to have the second condition. Notice here it's an and, not or. So I need to check both of them. Anytime we write just and, that means both conditions should be satisfied, not only one. Now, if it's a vertical tangent, same way, I need the slope to be undefined. If the slope is undefined, think about the fraction in general. When do I have the fraction as undefined? If I'm dividing by 0. So if b equals to 0 and a does not equal to 0. So it's the opposite. So here I check x prime equals to 0 and y prime does not equal to 0. Just easy way to remember, think about any fraction. It's equals to 0, numerator 0. It's undefined if the denominator is 0. Okay, that takes us to the next example. Here it's a one solved, just discuss the idea with you just quickly. So I need to determine the xy coordinates of the point where the following parametric equations will have horizontal or vertical tangent. So I have the two parametric equations and I need to check where do we have horizontal and vertical tangent. So the idea again, we know that we have a horizontal tangent, okay? I have a horizontal tangent if y prime of t equals to 0 and x prime of t does not equal to 0. Okay, let's try. We need y prime. Y prime, it's 12t equals to 0, so this is happening at t equals to 0. We have to check, this is important, I need to check that x prime of 0 does not equal to 0. Let's see. What's x prime? It's a 3t squared minus a 3. Check if it's 0 or not at 0. So this is x prime of 0, it's negative 3. So it does not equal to 0. It's correct. So this is a horizontal tangent. And clearly you see the horizontal tangent at t equals to 0. This is the graph of this parametric equation. Now, if I need to check for the vertical line, I need now the opposite. I need x prime equals to 0 for the vertical tangent. I need x prime to be equals to 0 and y prime does not equal to 0. Okay, so this is dx over dt. We needed 0. 3t squared minus 3 equals to 0. So t equals plus minus 1. And you have to check. This is important. You need to check whether y prime equals to 0 or not. So y prime 1 equals to what? Let's go back there. Y prime 1, it's equals to 12. Y prime negative 1, it's equals to negative 12. Both of them does not equal to 0. So we have to check both conditions again. It's and, not or. Now check here. It's clearly that I have a vertical tangent at t equals to 1 and negative 1. Okay, that's good. Now, the only part left for us here, we've checked the first derivative for x and y. We checked where do we have horizontal, where do we have vertical. But the question needs us to find the xy coordinate. So it's not enough to say at t equals to 1, at t equals to 0. We have to find it as a point. So if t is equals to 0, how do you find the point? Simple, just substitute in x and y. We have x and y. So this is the point x1, y1. When this curve has a horizontal tangent. Same thing for the vertical tangent. We replace at t equals to 1 and t equals to negative 1. I have these 2 points. So if you look here at this curve, this point is basically 0, negative 9, where we have horizontal tangent. And these 2 points, negative 2, negative 6, 2, negative 6, where we have a vertical tangent. So the final answer should be as order pair, point in the xy coordinates. Now one more. This is like trickier case. I need to check, but these are trig functions. Same thing, I need to check for horizontal and vertical tangents. In that case, when I need to check for horizontal and vertical tangent, I need to do what? I need to prepare dx over dt. This is equals to derivative of x. This is negative 2 sine 2t. If this is equals to 0, I need to find its zeros. Now, if it's equals to 0, that means sine 2t equals to 0. And when the sine is equals to 0, let's take here the interval. We'll take just only from 0 to 2 pi. For t, we'll take it from 0 to 2 pi. One full revolution. Now, when the sine is equals to 0, the sine is equals to 0 always at the x-axis, all the quadrant angles at the x-axis. So if I think here, at all the angles at the x-axis, we have the sine equals to 0. At the right-hand side, I have the cosine equals to 1. At the left-hand side, cosine equals to negative 1. For the angle at the y-axis, like 90 to 70, I have the cosine equals to 0. I do care mainly about the 0 case. So x-axis, the sine 0. Y-axis, the cosine 0. I mean by the x and y, the quadrant angle at the x-axis. So I have like 0, pi, 2 pi, 3 pi, 4 pi. All of these, we have the sine equals to 0. So I could write it as what? 2n equals sine is 0 where at 0, pi, 2 pi. Where do I stop? T is from 0 to 2 pi. If I need to consider 2t, so 2t will be from 0 to 4 pi. So let's consider the angles up to 4 pi. So 2 pi, 3 pi, 4 pi. I could write it this way, and anything after. I need t in the end, so I could write t equals, divide everything by 2, 0, pi over 2, pi, 3 pi over 2, again 2 pi, and we continue. So what I've done here, the sine equals to 0, 1 at the angles of the x-axis, which is 0, pi, 2 pi, 3 pi. How do I know where to stop? In general, this is everywhere, okay? We're finding general solution. But I need to check just some of them. Usually I take the domain. Domain is from, like, if it's 1 revolution, 0 to 2 pi. But here I have 2t, not only t. So I'll adjust the domain. So all times 2. So I'll take it from 0 to 4 pi, then no need to mention more, up to here. Now what will be t? Divide by 2. So either I do it this way or I'll solve it in general. So in general, the sine is equals to 0 at n pi, where n is an integer number, where n is an integer number. N belongs to integer numbers. Okay, but I prefer for now, let's just do the special cases. I'm not gonna do it the general case. Now this is dx over dt. Now let's find dy over dt. dy over dt. dy over dt, this is sine, so the derivative is 3 cosine 3t. And this is equals to 0 at the cosine. When the cosine is equals to 0 at the y-axis, what are the angles at the y-axis? So I have pi over 2, 3 pi over 2. When to stop? This is a 3t, so I need 3t. From 0 to 2 pi times 3 from 0 to 6 pi. Mainly it's enough to write up to there. Then the rest will be all repeating. So 3 pi over 2, and then I need all the odd multiples of pi over 2. Then 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. I guess here we stop. If I add one more, it will be 13 pi over 2, which is more than 6 pi. So no need for this one. I'll stop there. Now I don't need 3t. Remember, we need t. So t is equal, divide by 3, pi over 6, pi over 2, 5 pi over 6, 7 pi over 6, 3 pi over 2, 11 pi over 6. Now I'll highlight this. I need you to look at the solutions we have. This is the one which makes x prime 0. And these are the values of t which makes y prime 0. Now remember, anything in common between them, it gives the case of 0 over 0. So what's in common? Pi over 2. Pi over 2. 3 pi over 2. 3 pi over 2. So these cases where it gives 0 over 0, I'll exclude. No need to include them. Now what do we need to find? The vertical tangent. When do we have a vertical tangent? We know the vertical tangent, okay? Vertical tangent, if I have if I have it undefined, so it's x prime of t equals to 0 and y prime of t does not equal to 0, which is basically at which t? Let's try. So I'll take the values for t 0, pi, 2 pi. Could continue, but it would be all repeated. Now if I try at 0 pi, 2 pi, what will be the values in that case? I'll create a table. So at t0, I need the point xy. Remember, in general, the question needs us to find all points as xy. At t equals to 0, the point is 1, 0. Pi, 1, 0. Then 1, 0. So it's all repeated. So that means I have only one vertical tangent. One vertical tangent at the point 1, 0. One vertical tangent. Now what do we need to do next? We need to find the horizontal tangent. Okay, let's do it on the next slide. I need to do the horizontal tangent. Horizontal tangent means when y prime of t equals to 0 and x prime of t does not equal to 0. So basically, if we go back, this is where y prime equals to 0. So these are the values. Pi over 6, excluding the one with the red circle, because they are repeated. Anything in common, you exclude, because this will give the case of 0 over 0. So I'll take pi over 2, 5 pi over 2, 7 pi over 6, 11 pi over 6. Okay, let's try and create our table to check the horizontal tangent. So I'll start with t, and here I have xy. By the way, from where do I get xy? You go always use the original system, the original parametric equations. So if t is equal, we have pi over 6, and I have 5 pi over 6, and 7 pi over 6, and lastly 11 pi over 6. Now I'll check, you replace the values. This is half 1, half 1, half negative 1, half negative 1. Remember, we are always our concern about the values of x and y. If it's repeated, no need to mention again. So here basically I have two different points. So I can say that hence there are two horizontal tangents at the points. What are the points where we have horizontal tangent? Half 1 and half negative 1. So this is one of the questions that they are really long one. It needs studying all zeros. So I start with the two parametric equations. I prepare, since they need horizontal vertical tangent, I'll start with dx over dt. I check where it's equals to 0. Remember, the sign equals to 0 at the x-axis. So it's like n pi. So 0 pi, 2 pi, 3 pi, 4 pi. And then I'll find t. I'll do the same for cosine. Anything in common in between, I'll exclude them. No need to include, because this will give the case of 0 over 0. For vertical tangent, I'll take x prime equals to 0, y prime does not equal to 0. So no need to take the one in common. And then you create your table. If you need to check how many tangent do you have, how many vertical, you take the different points. Here, all of them the same. That's why I took it as one vertical tangent at 1, 0. Same thing for the horizontal. We took all the points where y prime equals to 0 and x prime does not equal to 0. And clearly that if I replace them into the xy, I have two different points. So basically I can say that I have two horizontal tangents at these 2 points. Okay, hopefully this is clear. Now the only part left out of section 9.2 is one of the important applications. We use the calculus of the parametric equation just to find the area, okay, described by a curve that is traced out once exactly. So the area enclosed by a curve. So instead of using the f of x, okay, or regular function f of x, which is y equals f of x, this time we'll try to represent the area using our parametric equations that we've learned in this section. So let's say if I have a curve y equals f of x and they give me x's between a and b, and it's described by the two parametric equations x equals x of t and y equals y of t. So where this curve, this is the important part here, so with this curve is traversed exactly once for t between c and d. So just like a closed curve, okay, and there's no overlap. You start somewhere and you end up at the same point. Something like a circle, an ellipse, all these closed shapes that there's no overlap. If the function is greater than or equals to 0 over this interval from a to b, then how do we write the interval, or how do we introduce the parametric equations? So f of x is basically y dx. If I change y into y of t and dx as x prime of t, you look at this one just something like this. So it's y of t x prime of t dt. Since we change it in terms of t, okay, so I need to take the boundaries of t. So t is between c to d, not a to b. So now this is the integration from c to d y x prime. Now there's another form of this area. We could write it in this way as the integration from c to d xy prime. The only difference in this case, if we switch them, is only a negative sign. And usually it depends on the orientation. How do we trace out the curve? So if the orientation is clockwise, they use with y x prime positive. The other one will be negative. If it's counterclockwise, with y x prime, it will be negative. The other one will be positive. So it's just good at least to know one of them. Clockwise, the rule with y x prime is positive. So it's easy to recall all the others. To make it much easier without involving the orientation, if it's clockwise or anti-clockwise, remember this is an area and the area can't be negative. So anytime if I'm dealing with a function and I'm finding the area, okay, so if it's negative, you can always take the absolute value to make it positive. Okay, you can from your result check if it's clockwise or anti-clockwise. So if let's say I'm using this formula, the first one, okay, assume I'm using y x prime. So if I'm dealing with y x prime, okay, and I got positive, so I know it's clockwise. If I'm using y x prime and I have negative value, so I know it's anti-clockwise. Okay, so just from the rule you can check. So don't worry about the negative, use the absolute value. Now the first question we have is this. We need to find the area enclosed by the curve x equals 2 cosine of t plus sine 2t, y equals 2 sine of t plus cosine 2t. Here they didn't give me any interval, just t is changing from where to where. What's the interval for t? So I need to think about an interval where this curve will be traversed only once, okay, without an overlap. So just thinking about the domain of sine and cosine, the domain for them is only 2 pi, okay? From 0 to 2 pi, you have one period of this curve. One period of sine and cosine is 2 pi. But what's the one period of sine 2t, cosine 2t? It's only pi. Now, if I think about the least common multiple between pi and 2 pi, so it would be 2 pi. Remember always the domain equals to what, or the period? The period for sine k t, let's say, the period for sine kt is equal to what? Is 2 pi over k. This is how we usually can find the period. So it's 2 pi always fixed divided by the coefficient of the argument here. So this is 2, so 2 pi over 2, that's why it's pi. With sine, you know, this is the basic one, so it's 2 pi over 1, which is 2 pi. Now, this means that I can take the interval from 0 to 2 pi, okay? So I can add that t is between 0 and 2 pi. To be sure that there's no overlap, you can always check x of 0, that it should be equals to x of 2 pi. Same thing for y of 0, it should be equals to y 2 pi. And if you just check these two, you'll find that they are equals to each other, which means that there's no overlap. So the graph would be closed curve from 0 to 2 pi, and there's no overlap. Okay, there's no overlap. Okay, now let's try to find the area. Now I'm not gonna just, if I need to check the orientation, I can, okay? But let's use the idea of the absolute value. So if I'll take the area for the integration from 0 to 2 pi, or we'll use x of t, y prime of t dt. You could do the opposite, and it should be the same answer. Just the only difference usually is only a negative sign. So now this is equals the integration from 0 to 2 pi. What do we have as x of t? That's it. It's 2 cosine of t plus sine 2t. And what's y prime? Let's find the derivative for y prime. It's 2 cosine of t minus 2 sine 2t dt. For this integration, okay, we could just use the calculator directly to check it's equals to what, and it will be equals to 2 pi. It will be already positive. Okay, it will be already positive. Now what will be the direction? You see, now I can guess the direction if it's needed. I use the formula for xy prime. Check this slide. I've used the xy prime, this one, and it's positive, there's no negative, which means that the orientation is counterclockwise. Okay, so anytime I get directly positive result with xy prime, so this is counterclockwise. If I used yx prime and it's positive, so it's clockwise. If you like just to check the orientation, remember you can always take any 2 points. Just for like self-checking, you can always take any 2 points. So let's say if I take 0 to pi over 2, 0 will be equals to 2, 1, and pi over 2, 0, 1. So clearly that this is counterclockwise. This is counterclockwise. Counterclockwise. Okay, let's see one more, another question. This is the solution for the same one. This is another question that I did add already the solution for you. So if I have cosine of x sine 2x, okay, cosine x sine 2x, 2t, sorry, and we need to find the area from t equals pi over 2 to 3 pi over 2. From pi over 2 to 3 pi over 2. And I've used the rule of y x prime. By the way, if I need to check the orientation, you can easily see that this is clockwise. This is clockwise. So for this rule, I'm expecting a positive result. Now, if I find the integration y x prime, y is already sine 2t. X prime, it's negative sine of t. Dealing with sine 2t, I can always use the double angle identity. So sine 2t, I replace it with 2 sine cosine. And there's already another sine, so it would be 2 sine squared cosine of t dt. I keep the negative outside. Now here, this is like classic substitution. So you used u as sine. Remember the case, this is sine squared cosine. So this is the classic substitution. U equals to sine. This is its derivative. So you can easily find the integration as 2 over 3 sine to the power of 3 t. Remember to substitute the boundary. So if you substitute the boundary, you'll get 4 over 3. You'll get 4 over 3. Okay, that's all. Section 9.2. Next time we'll be dealing with even much more with the graphing in section 9.4.